This is Carl Dong, and you're listening to Firewalls Don't Stop Dragons.
Hello, everybody. Welcome back to Firewalls Don't Stop Dragons. I'm your host, Kerry Parker. Today we have episode 430 for May 26th, 2025. First of all, happy Memorial Day to those in the U.S. I always remember Memorial Day back as a kid growing up in Indiana because the Indy 500 was always Memorial Day weekend. Honestly, I'm not a car guy. I have not watched that race in a very, very long time. But I know it's a big deal for this weekend, so hopefully you guys are having a nice extended weekend. You got, I guess, the remainder of today. Usually you get Monday off, so I hope you're having a good weekend. As you hear this episode, I am home, but I just got home, and I'm recovering from my very long and hopefully enjoyable vacation. So again, like I mentioned last time, if there's any major happenings while I was away, and for some reason I am not talking about them right now, that's why. But we'll have a new show for you next week, and I will catch up on anything that has happened while I was gone. All right, so let's set up this interview. I've talked about VPNs a lot. We've even had interview shows focused around VPNs, in particular the Tunnel Vision episode, which I thought was really interesting. And I had a new show where my tip of the week was talking about what a VPN is and what a VPN isn't. That was titled Demystifying VPNs. Got a blog article about that on my website as well. VPNs are often touted by the companies that make them as a silver bullet for privacy, and they really aren't. I mean, VPNs weren't built for privacy, despite the fact that it's called a virtual private network. It's really about security, not privacy. Back in the day, this was the technology that you would use as a remote worker, either because you were traveling or because you just didn't work in the main office, to access your company's private network. And so it was a virtual private network. It allowed you to access file servers and send emails and do the kind of things you could do if you were in the office on the private network without actually being in the office. Now, we've since tried to use these same technologies to help guard our identity, in particular to try to mask our true IP address, which can be used to identify and track us. And we've also used it to encrypt our traffic if we don't trust our internet service provider. And we've got a lot of good reasons not to trust our internet service provider, but more often we might use it on a public Wi-Fi network if we're at the coffee shop or at a hotel, or these days on an airplane, though. I don't know how well VPNs work on the airplane Wi-Fi. I actually don't. I don't use airplane Wi-Fi. I don't know why. I just sit out those couple hours and, you know what, just get off the grid. But anyway, if you are worried that your connection point to the internet, which at home is your internet service provider, while you're out on the street, it's your cell phone provider, or when you're at a coffee shop or a McDonald's or a place with a free Wi-Fi hotspot, it's them. And if you don't trust them, because they could potentially look at your traffic, then you could use a VPN for that. And it works very well for that, actually. But for people who really care about privacy and who want to be as anonymous as possible, and it's difficult on the internet today, we really need something more than just your standard VPN. So the Tor network, which is something we've talked about before, is an effort that has tried to address that need, but it's kind of slow and clunky, and it's slow enough that a lot of people can't stand using it. Apple has come out with something called Apple Private Relay, which I think was fantastic, which is basically a simpler and yet still privacy-preserving version of Tor, and much, much, much faster, like to the point where you shouldn't notice a difference. But it's very limited in scope. It only works on Apple products, and in fact, it only works on Safari and some Apple apps. And so Carl Dong has created basically Apple Private Relay for the rest of us. And it's about splitting your trust between two different parties, and you don't have to trust just your VPN provider. It's kind of a split VPN provider. We're going to get into all the details today, but it's a very interesting concept, and honestly something that I think any VPN today that it's trying to help you preserve your privacy really needs to be doing. So as usual, let me talk a little bit about some of the lingo you're going to hear. I'm not going to sugarcoat this. We're going to get into some technical stuff today, and we're going to throw out a lot of technical terms. But you don't need to understand really any of these technical terms and jargon. I'm going to quickly walk through some of the things you're going to hear today, but don't worry if you don't understand what these things are. You really don't need to understand what these things are, but I want you to know what he's talking about, so as they come up, you can understand why you can ignore them and not worry about it. First of all, we'll talk about the Great Firewall of China, and this is just kind of a metaphor for how the Chinese government is trying to block external access to the internet for its citizens. There really is a technical sort of a firewall there, but it blocks connecting to certain external services, like I believe Facebook and things like that, and using tools like VPNs because they want to be able to monitor everything you do. There have been a lot of VPN protocols over the year, the underlying communication and technical mechanisms that make these things work. L2PT, PPTP, OpenVPN, and more recently WireGuard, which we're going to talk about today because it's really the current modern best standard. But these are just flavors of VPN technologies that you don't really need to know. We talk about TCP and UDP. These are transport layers on the internet. We also talk about QUIC. That's QUIC, which even though it's in all caps, apparently doesn't stand for anything. It's not an acronym, but it sort of replaces the standard transport layer for HTTP. And don't worry if none of that means anything to you. It's just know that it's really fast and efficient. Related to that is something called MASC. That is an acronym. It stands for Multiplexed Application Substrate over Quick Encryption. Man, they really torture some of these acronyms sometimes. We do talk about a man in the middle. Sometimes that's called a manipulator in the middle or a malevolent person in the middle. They keep trying to change it because, it's an old term and we're trying to not be sexist with our terms. But a man in the middle attack, or an adversary in the middle attack, is when somebody manages to situate themselves virtually between you and the rest of the network, or at least between you and certain targets on the network. And if they can place themselves in the middle, they can see the traffic that goes back and forth, and perhaps use that traffic to identify or track you. Or, in some cases, actually try to install malware on your machine. But today we're mostly focused on privacy and not security. We talk about the Bitcoin Lightning Network, and that's a whole other topic. But Bitcoin is not super anonymous out of the gate. Not as anonymous, certainly, as a lot of people think it is. And it's gotten really kind of slow in its old age now for processing transactions. And so there's another layer now on top of Bitcoin, an L2, a layer 2, that is trying to address that need and also to add more layers of privacy. And the only reason it comes into play here is because this particular VPN has the capability to be paid for over the Lightning Network, which means that Carl Dong's company knows almost nothing about you. And then finally, a couple other networking terms. We talk about VLANs or virtual LANs. A LAN is a local area network. This is a kind of a virtual segmentation of your network that you can do just through configuration so that, these devices over here can't talk to those devices over there, even though technically they're on the same physical network. Virtually, they are separate. And finally, we talk about DHCP. That is the Dynamic Host Configuration Protocol. This is the technology that allows your device, when it first connects to a network, to say, hey, I want to be on the network. Can you give me my own address so that I have a unique sending and receiving address for all my data packets? And then one more, even more esoteric term is this option 121 or option 121. This was key to the tunnel vision vulnerability. Maybe that's a strong word. It really is kind of a feature that has been turned into a bug in certain situations. But it allows your router, who hands out these IP addresses and helps route your traffic to the broader internet, to bypass your VPN if you're not careful. So that's a lot of technical terms. I'm sorry there were so many. Don't worry about them too much. I just want you to know kind of what they are when they come up so you can feel free to ignore them and not feel like you're missing something. So that's a lot of setup. Let's get to our interview with Carl Dong. Carl Dong is the CEO and head janitor of Obscura, a new VPN service fighting for the open and private internet. Carl's an avid networking and systems engineer nerd and was previously a Bitcoin Core software developer. Welcome to the show, Carl.
Glad to be on here, Carrie.
This is really interesting, and I'm glad you reached out to me. And as we were kind of talking before the show, when Apple came out with Private Relay, I'm like, why are other VPNs not doing this? And well, here we are. You're doing this. So we're going to get into that today. But there are lots, maybe even too many VPNs out there, right? So what problem were you trying to solve with Obscura that wasn't already solved? And maybe what personally nagged at you enough to create your own solution?
Yeah, 100%. I think, to roll it back a little bit, it sort of helps to have a little background of like, why am I even interested in VPNs in the first place? Right? It seems a little bit of a niche subject, and perhaps people are like, well, isn't it solved already? So I grew up sort of all over the place. I grew up I sort of was born in Shanghai. I went to London for primary school a little bit, where I got used to using, Wikipedia and Google and YouTube, Facebook, all those things like that. Went back to Shanghai for a few years, and that's sort of when the Great Firewall came up. That I love that that's in the title of the show, and so I got to using some of the commercial stuff that's out there. There were already a couple of VPN companies out there, and also trying to build my own, right? Back then, I think it was L2TP and PPTP. Those were sort of the old protocols that were out there. And then came Strong Swan and OpenVPN, and then sort of eventually WireGuard, right? And throughout the years, every time I go back to visit relatives and all those things, I sort of test, my new setup against the newest and greatest Chinese firewall. Like, what mitigations are they putting on, and what do they do here? And so there's a lot of learnings throughout that. But I've been an avid user of VPN services, and there are a bunch of problems that I saw. I think one of the problems that I think is particularly salient, let's say when I go visit relatives, is just access, right? It's like, if you connect to the VPN itself, okay, it all worked fine, but can you even connect to the server at all, right? So the Great Firewall might be blocking access not only to Google and Facebook and whatever, but it might also be blocking access to these VPNs itself, in which case you just can't do anything about that. A lot of the things there, I think, had to do with, okay, what, I at the time I was already really into computers and trying to understand networking protocols and all those things. A lot of things it had to do with, what do your packets look like on the wire? What does your traffic look like, let's say, and is it easily identifiable as VPN traffic and things like that? But the second problem that sort of that really bothered me, I think, after I got a better sense, after being educated in college and looking into Bitcoin and things like that, and thinking about different security models, is the trust aspect for it, right? We're just talking about access. Now we're talking about trust. Is the fact that I felt like I'm paying for a man in the middle. Basically, I'm paying for a man in the middle that's like a privately owned company.
Right.
And over time, you start to see, okay, they were great, but now they're sort of adopting some user hostile, tactics and things like that. I get, as the business, growth is important. It's not a charity and things like that. It just ticked me off a little bit, just because it is, basically in this digital world, our internet is most of our lives, right? Most of the things that we do that are notable happen over the internet. So we should basically have a higher bar in terms of trustworthiness and everything else, right? And also, being someone who is really into the technical details of things and the different protocols, I saw really slow adoption of WireGuard in the industry, which I thought was extremely, extremely... It was just weird to me, because when it released and I saw what it did and how it simplified things, and just like comparing that to the monster that is OpenVPN with all of its extensions and things like that, I thought that was just a no-brainer for any company that was sort of in touch with the core of their business, their core business technical assets to do. And it was, WireGuard first announced 2015. There was a really slow adoption curve of like 3, 4, 5 years before some of these major vendors started adopting them. So I thought that was peculiar, let's say.
And so you start Obscura. And you're right. When we use a VPN, we're really just shifting our trust from our internet service provider or wherever our first hop is. It could be the coffee shop or the airport or the hotel, wherever it is we're getting first access, right? You're shifting your trust from them to your VPN provider, because for most VPNs, the VPN provider can see everything you're doing, right?
Yeah.
So how does a multi-hop VPN like Obscura address this problem? And how? Right. And there's only a couple of those that I know off the top of my head, and that's Apple's Private Relay and, of course, the granddaddy Tor. So how does Obscura differ from those?
Yeah, well, maybe it's useful to have a little bit of detail on like how Obscura differs from a traditional VPN at the beginning, right? So with a traditional VPN, your traffic goes to the VPN server, whether it be, Nord, Express, one of the big ones, and then out to the internet to Google and Facebook and YouTube and things like that, right? So their VPN server, as the only middleman that you pay for, they know who you are because they have your email, your billing address, your yada, yada, yada. And they can correlate that with what you're doing because they know that you're going to google.com and YouTube and things like that, or perhaps, WikiLeaks or something like that, right? With a two-party relay VPN, and I want to make a point here that this is very different from what some VPN companies call multi-hop. With a two-party relay, what you're essentially doing is you have two parties that go between you and the internet. So your traffic goes to the first party, then the second party, then to the internet. With Obscura, that's your traffic goes to Obscura, then Mullvad, then to the internet. And it being two parties is really important. And I'll detail that later on. So with this two-party scheme, right? The first party, Obscura, we know who you are because we know that you've paid for an account and things like that. But we have no idea what you're doing because you connect directly to us. We know who you are, but we don't connect you to the internet. We don't connect you to YouTube or Google. We have no idea anything about your internet traffic. Now, on to the second party. The second party doesn't know who you are. It just sees, 1 out of 1,000 connections coming from Obscura, right? So Mullvad sees 1 out of 1,000 connections coming from Obscura, but it knows what you're doing because it's the party that's connecting to YouTube and Google and Facebook and things like that, right? And so with this scheme, and because that these are two parties, separate entities, no single party can then correlate who you are with your traffic, right? No single party has simultaneous access to both. We're sort of just tying one of our hands, let's say, in each case. And so it offers much better privacy than the rest. Nobody can unilaterally de-anonymize you, let's say. And I think this was a really ingenious scheme that the Apple Private Relay folks said. I remember when it first released, I was like, "Oh, that's interesting that they're doing a VPN thing." I'm sure it's some, I'm sure it's not very notable. And then, like, I think a half year later, I was at a bar hanging out with some of my Bitcoin developer friends, and they were like, "Hey, Carl, you should check out Apple." I was like, Apple's privacy stuff. And then I looked at it and I was like, whoa, this is so interesting. Like just the scheme itself, right? Because it's not relying on anything magical. It's just sort of by design, and it's somewhat easy to understand. It's almost like, having a PO box or something. It's a very easy to understand scheme that's quite easy to implement as well. And so the differences from Apple iCloud Relay there's a couple of minor differences, right? One of the things is that Apple iCloud Relay only works in Safari for Mac and iOS. I'm sure that there are reasons for this and things like that, but we're a general sort of IP layer VPN in that we sort of work for all of your IP packets. The second thing is that They use a standard from the IETF called MASC. So MASC, it's a very good acronym, but backronym, I would say. And I actually went to some of their working groups at the IETF to talk with the people who designed a lot of this. But MASC operates over HTTP3. I think the main reason for operating over HTTP3 is because at the time, because this is sort of a two-hop thing, Apple had to partner with somebody for the exit hop. It's just like how Obscura had to partner with Mullvad for the exit hop, right? Apple had to partner with people like Cloudflare and Akamai and Fastly, and they were best. They were really good at working with HTTP, not so much a lower layer. When we took a look at the protocol, we said, okay, actually, this would be a lot easier if we just implemented over Quick, because Quick implements all the things that we would want for this anyway. So why not do that instead of adding another layer? So that we get a little bit of more performance actually from that, because we can stuff more into the packets. That's less overhead. I think for the difference from Tor, and I want to say, I love the Tor project. Very sort of inspirational kind of project for anybody who cares about networking and privacy, I want to say, right? And to any listeners who are looking for a worthy cause to donate to, please, Tor project, definitely. And I don't want to overstate things, but basically you can think of us like we're Tor with 2 hops, but where the 2 hops, we use dedicated high-performance servers for these hops instead of Tor, where it's a free participation, volunteer-run network. I think it's a bit of a different use case, right? We have immense respect for them, but I think anybody who's used Tor can testify that it's not really optimized for everyday use. And if you are using it every day, please talk to me, because I would like to know how you make that work. That would be amazing. So with Obscura, we really care about the user experience and how smooth the connection is. We don't want you to feel like, you're being crippled or anything like that just because you have privacy. And so, that's what, I'm talking to you through it right now. And, I use it for all my calls and, streaming 4K HDR video. It works totally fine, totally smooth, not even recognizable. Yeah.
You were talking about basically what we call KYC, know your customer, right? And that comes into play largely, certainly from your background with Bitcoin and financial stuff. But I mean, any company that's going to sell you a service needs to know, well, they at least claim to know, they need to know something about you in order to provide that service to you. And yet you guys have really gone to kind of great lengths to know as little as possible about your users. So what information is required to set up an Obscura account, and like contrast that against what you might have to do to set up other accounts, even some of the other more private ones?
Yeah, 100%. I think for us, we've always taken the stance of user data is toxic waste, but with a little bit of an asterisk. The asterisk, I think, is that sometimes the user wants more convenience, and I think that privacy is a spectrum, and if the user is willing to give that up, let's say for more convenience, then we're not going to stop them, and we're going to make sure that even in that case we have the most private option available, right? The most private convenient option. So the difference for us in terms of, knowing stuff about our users from most VPN providers mostly has to do with the personally identifying information, right? Most VPNs require an email to sign up and to track an affiliate link and to have billing addresses and phone numbers and et cetera. And I stress require, right? As in like you have to give it to them. For us, for logging in, we don't require your email. We just require that you generate an account number locally. And this is just a random string, basically, with actually a checksum at the end, just in case you miswrite down the account number, because it's quite important that you keep your account number. And this was inspired mostly by Mullvad's scheme. I think they were sort of the pioneers in this, in that, let's just think about, we want to provide this service. What is the least amount of information that we can collect in order to still provide the service, right? And for a VPN, it really is an identifier, let's say, to make sure that you have paid, and some kind of way to pay so that you can pay. That's it. That's basically all we need, right? And so that's for the login side. On the payment end, we've integrated Lightning, which is the L2 protocol for Bitcoin. In Lightning's case, it has much better sender privacy as compared to Bitcoin. We basically don't know anything about our sender and who they are when you pay with Lightning. And I encourage people who care about privacy to use Lightning for it, and also instant settlement and things like that. Or, well, within a few TCP round trips. And on the payment end, you can also pay with Stripe, in which case, if you're paying for a top-up, we don't require your email, and we had to finagle Stripe's API so that that's the case. And if you do a subscription, it's legally required to collect an email, so you can. But we offer all these other options, so pick your poison, I guess, yes.
Legally required by whom?
Well, I think Stripe is legally required by the government to do that. And also we are legally required by the government to do that.
Okay, so a lot of my audience has probably heard the term Bitcoin, but probably has no idea what the Lightning Network is or how that works.
Oh.
How does one get into the Lightning Network? And I'm assuming if you're going to go to the links to do this, you want to be anonymous. So how does one get into making Bitcoin payments anonymously to you or anybody? Yeah.
I would say download any one of the Lightning wallets. You'll see like a deposit address, and most of these are some of these are self-custodial, like Phoenix and things like that. Actually, my wife works on the Rust implementation of Lightning at Square Block, actually, and it'll generate you a Bitcoin address, which you can deposit into, and it does some magic such that you open up a channel and does Lightning and things like that. I will say that I think, on a lot of other blockchains or whatever, they have gotten into this whole war of like multiple L2s, and everybody's like shilling their own L2 with a coin and things like that. Bitcoin's Lightning is just like the one L2 that works and has stood the test of time. And we receive money very reliably through it. And we've been very happy with how it's worked, because we were very thoughtful in the design of how Lightning works.
I am sure that Seth asked you this question because I think you were on his show.
Oh, yeah.
He must have asked you about the support for Monero. What's your story for Monero?
Yes. So I've talked to Seth, and he's been very, very helpful through all this. Monero is coming soon. We're looking into how to implement it, but Monero is definitely coming soon.
Oh,
and
you can
hold me to that. If it's not coming soon, Seth, I already have a deal with Seth where every time he sees me, he has to bug me about this, just so it's top of my mind. So yes, let's do it.
Fantastic. All right. So the other thing you mentioned this earlier too. One of the other ways that VPN privacy can bite you is logging. And for the uninitiated, this, whenever you're writing software for servers, there's logs galore. I mean, when you're running services, and this is how we debug things. This is how we audit things. This is how we know that things are working properly. This is a sequential text file with timestamps of things that are going on. And a lot of things that are often logged in cases like this could be your IP address or associated with your account ID and things like that. And so that if, for example, if the cops were to come knocking with a warrant and say, show me all your logs, because we think that Carrie was using a VPN to do crime on this date, show me all your logs for this date, and then I could, see what Carrie was up to. You claim, well, actually, I'll let you make the claim, but the VPNs that are privacy-oriented claim that they don't have logs or have minimal logs. So this could be a problem. So how can I ever be sure that it's not just marketing, that the VPN providers that say they aren't logging really aren't logging? I know that some do third-party audits, but I mean, even third-party audits can be, let's face it, some of those can be kind of contrived and not as full as they should be and not really meaningful. Sometimes they're just marketing. So what do you do, and how do I know that you do what you do?
Yeah, I have a couple of points here, so I'll sort of go through all of them. I think, for a lot of VPNs that are promising no logging, I think, there are a lot of very trustworthy VPNs out there that claim that. And I believe them. I mean, a lot of them has had a really good track record of doing the right thing and standing by their customers, actually wanting to do good by their customers. But it's, let's say, not about the promise. It's also about the possibility, in that even if these providers, let's say, are not logging, who's to say that a malicious party, let's say, can't, hack their servers or find some vulnerability to get in there and implant a malware that does log, right? And so they could totally be 100% honest about what they're saying, but still have that vulnerability. I think in sort of working in Bitcoin and things like that, I'm sort of taking the stance of, if there is a way to get rid of the possibility of doing something, then that's the better answer, let's say, right? It's sort of like the zero trust. I'm sorry for throwing a buzzword out there, but the zero trust thing that people throw around in security circles these days, right? And so for us, it's about not just promising no logging, it's about making sure that our infrastructure can't log, right? I was just talking before about our two-party relay infrastructure. We've made it such that we physically can't see your traffic. Like, we could log the random packets that are there. It would make no sense and be of no use to anybody, other than, let's say, the hard drive manufacturers' revenue. But there's just nothing to log. So I think that's the bar that we want to set for the industry. And I hope that the industry adopts this. I think that this is really where the industry should be going. In terms of trust and third-party audits, I think there's a nuanced point to be made here. I think it's really good to have audits, right? It's certainly better than nothing, right? It's definitely good to have third-party audits. In fact, we're about to undergo one in a few weeks, and we're excited to go through all of that. I think where the tiny flaws, let's say, in third-party audits that people may not fully see sort of out of the gate, is that an audit is only an audit of a snapshot of the code base. Yep. So it's that code base at this time. Right. And code base has changed, architecture's changed. So by the time you're connecting, perhaps it's not something that's the audit, but still good to have, let's say, right? And another thing is, and this is why we've been working on reproducible build. Well, why I worked on reproducible builds when I was back working on Bitcoin is, if the app isn't able to be reproducibly built, then what is the point of the audit, right? You could be auditing something that's completely different from what's being released to the to the user, right? And for the audience here, reproducible builds means that, let's say we have a company that sells VPNs, and they say, hey, here's all our source code, right? You can read your source code and see that it's good. Well, what's to say that the disk image or the zip file that you download from them actually corresponds to the source code that they're releasing, right? There's no, they could before release just add a little backdoor in there and then, compile something. Reproducible builds means that there's some script or some process that you can go through where you can download the code base and build the app itself, and the end product is exactly bit for bit what you download from them. So you can make sure that, the source code that you're reading corresponds to what you're downloading. And so I think that's extremely important and sort of bridges the gap in this sort of trust chain, let's say.
And it's something that's often overlooked in open source software.
Right. Well, because it's hard. Quite difficult. It's quite difficult.
It's hard.
Oh yeah, 100%. I think years of just relying on, macros and things like that make it quite difficult. Yes.
Well, and I think the point you're making, and this is something that I think Apple has tried, and other privacy-oriented companies have really tried hard to do this, is at the end of the day, you really want to engineer your solution so that you can't provide information. Like, you don't have it to give, or what you have to give is completely encrypted, which, sure, you can hand that over, but if the encryption's done right, it's pointless. I mean, there's nothing to be gleaned from it.
Exactly. I think that's exactly
engineering yourself out of the problem is really what you're trying to do, and that's
engineering myself out of the problem. That's exactly right. That's exactly what we're trying to do. And I think there's there's a point to be made of it's all about trust minimization, right? Given the tools, let's say, that we have at our disposal, I think there's often sometimes people have an all or nothing mindset about privacy and things like that. I don't think that has to be the case. We do what we can with the tools at our disposal, and we try to do as much R&D as we can such that we can minimize trust even further. And which is why I was so excited when I saw this private relay thing. I was like, oh, this is like a brand new tool that we have at our disposal. Fantastic.
Yeah, it's really cool. I mean, you're splitting trust, right? It's a now you'd have to, the two of you and Mulvad would have to collude, or someone would have to compromise both of you, basically.
Right.
Which makes it harder. All right, so using VPNs does have some quirks. I think, for example, some websites, rely on your IP address to guess where your location is. If you want a weather forecast or restaurants near you or things like that. And are there any strange, I can only imagine with the two ops, are there any strange behaviors that are particularly associated with multi-hop VPNs, or do they have the same kind of quirks? Yeah,
it's mostly the same kind of quirks. For multi-party relays to the website, it just looks like you are, a single party relay, at the exit node, right? So not more so than traditional VPNs at all. I think for functionality and things like that, I'm totally, sympathetic to that use case. For us, it's about changing the defaults in what the website knows, right? They shouldn't automatically know your location just by the fact that you're connecting them and asking them for something. It should be an active action that, hey, we would like to know your location. Would you like to share your location, or things like that? I think that's a better way to do so. But I also think that one of the things that I think is going on in the industry, and I think we're going to have a good answer for, is split tunneling. I'm not sure I quite like the word split tunneling because it seems so technical and what is it actually doing and things like that. So in simple words, it's like, okay, you're visiting your bank website. It already knows everything about you, right?
Right.
Maybe you don't have to go through a VPN for that, and maybe they're blocking you. So maybe there's a way for, just that website to bypass that. Now, it's somewhat difficult because, websites can refer to other websites and make calls to other websites. Now, does that go into the VPN or not? Things like, cross-site scripting and things like that. But I think split tunneling is one effort that's sort of happening throughout the industry, and people are looking at different ways to do it. And I think we'll also look into different ways to do it.
So you bring up part of my next question is that one of the more trickier things with VPNs is that a lot of websites and services don't like VPNs, for various reasons.
Right.
Some is fraud. Some is because they've got copyright licensing agreements that don't let them, access stuff outside of your region or whatever. Does the multi-hop VPN does that have the same kind of problems? Does you find it triggering CAPTCHAs more often? Do banks say, sorry, you can't connect from that thing because it's VPN. We don't do VPNs. Again, does it function the same from their perspective as a regular VPN, or
yes.
Is there anything? Okay.
Yeah. So from that perspective, we basically look the same as if you were just connecting to Mulvad directly. But I want to talk about sort of the underlying problem here, right? It's a very interesting problem. It's a problem that I think plagues the industry, and it comes from the fact that the previous generation of network security software, let's say on the server, on the website end, relied heavily on IP reputation. I don't blame them, right? There are just IP ranges where botnets come from a lot. But it turns out it's a blunt tool that hurts honest users who simply wish to have more privacy. And so we saw advancements in this space. I think a history of those is, first of all, CAPTCHAs. Now, I know that CAPTCHAs might not seem like an advancement, but let's say it really is, because the alternative is just completely blocking you, right? Completely just not allowing you to even access the website. So a CAPTCHA, I think, is better than simply blocking. But I think the CAPTCHA was the solution for 5 to 7 years ago. The recent advancements in this space that are really interesting are things like Privacy Pass, where you can get an attestation from some sort of entity like Cloudflare, like, I don't know, Apple, like somebody that says, hey, this is a real user. Maybe in Apple's case, it's like, hey, this is a user that paid like $2,000 for their laptop. Right. This is probably not a bot that's trying to access you, right? And, Cloudflare did something very interesting with their initial Privacy Pass browser extension, where if you solved a Cloudflare challenge, let's say, it would issue you a couple of privacy passes that are cached in your extension. And so anytime you access Cloudflare websites, they would send that along, and it would privately identify you as a real human. And so you don't have to like keep doing captchas on each different site. I hate the ones where they just fade really slowly. I'm like, nobody has time for this. So Privacy Pass is really interesting. Another thing that's really interesting, I don't know if you've seen Anubis. Anubis is this new proof of, it's just like, I think a month ago it started picking up steam, and then a bunch of sites like the GNOME GitLab, the Linux mailing list and things like that kept picking it up. So it relies on proof of work, actually, similar to Bitcoin. So proof of work, it means that when you visit a website, the website's going to be like, hey, solve this somewhat complicated puzzle, let's say, but this puzzle is for the computer. So this computer solved this puzzle, right? And so you just wait there until your computer solves the puzzle, and then it lets you in. And it remembers that your computer has solved the puzzle. And so when you refresh the page, it's not going to ask for it again. What these are great for is making it expensive for bots to attack or to scrape, right? If you think about the cost of, let's say, to 10,000 really low-powered IoT devices that have been taken over by some botnet somewhere, to do this is going to take a long time, and it's going to be really expensive for them to do. And this is in a way that's quite decentralized, in that you don't need any kind of central authority to issue you any tokens or things like that. I would like to see more stuff like this being standardized. But I think the general trend in the industry for network security is moving away from IP reputation, or moving away from over-reliance on IPs, and using things that are sort of more up the stack in terms of being reputation and guarding against attacks and things like that, which we're happy to see, and we'll definitely, champion and write articles about it and things like that.
All right, so it kind of seems to me that any tool that provides anonymity on the web today, unfortunately, is in danger of being undercut by governments who don't want anything that they can't trace or surveil. Bitcoin and some of the, like some of the mixers, for example, when they're trying to kind of, I love the analogy of the mixers. Like everybody throws $20 in a hat, and then you pull a 20 out, and you don't know whose 20 was, right?
That's a good one.
That's the way I love to think about mixers. But it anonymizes the cash, and governments really don't, especially when it comes to money. But I mean, we're seeing pushback in a lot of Western democracies against VPNs, and certainly things like Signal, things with end-to-end encryption. So do you ever worry that Obscura, being so privacy-oriented and being almost damn near anonymous if you really set it up right, being shut down or maybe defunded? A lot of times they come after your funding. A lot of times they try to, get Visa and MasterCard to get cut off so you don't get paid. Do you worry about that at all? And I'm also curious, does the split responsibility model with you and somebody else, does that make it harder or easier if I was a government wanting to shut this down?
Wow, that's a very deep question. I would say that, we're pretty practical in this regard, in that, okay, the government has the monopoly on violence, let's say, right? And so, if they really were to come to our door and bust it down and put a gun to our heads, we could be shut down, right? If they just pulled power to all of our data centers, that's just what happens, right?
Yeah.
What we are more concerned about is, can we be influenced? Let's say, right? Can we be influenced?
That's actually more insidious, yeah.
Right, that's the more insidious part that we're more concerned about. And one point I'll say about sort of the shutting down and being concerned about sort of governments and things like that, I think that a free and open internet is really worth fighting for, and that we should not let any sort of chilling effect take place. I think that if there is a fight worth fighting for in sort of our digital age, this is the one. And so that's why we wake up in the morning. That's why we do what we do, right? So even if it were the case that it is a little bit risky, or somebody says something here or there that makes you think it's risky, we're going to keep fighting this fight and just see what comes. But more on being influenced. This is what we thought about the most, right? And this is why transparency is such a core part of everything that we do, right? We do a two-party relay, which means that even if our servers were hacked by someone or influenced or swapped out with another server, we still physically don't have access to your traffic, right? And vice versa for Molvad as well, right? Like Molvad won't know who you are if even if they were influenced or hacked or things like that. I think that's a really good guarantee to have. We design our client software such that you don't need to trust the server at all in order to have privacy. The server could be swapped out. At the end of the day, reproducible builds that we're working on, we can't introduce new vulnerabilities on the client software into the code without it being published for the world to scrutinize and see, right? We can't release, once we have it, we can't release builds where, somebody just maliciously inserts a little backdoor in there before release without people being like, hey, I can't reproduce this newest version. What is going on here? Right? And so these are all things that we think about, and that is the thing that we're most worried about, the insidious nature of being influenced. And I think we have a very, very good mitigations against that.
Let's get a little bit technical, and we'll have to define some of these terms as we go, and you've already thrown a couple of them out, so this is a good opportunity for us to talk about them. We've talked about WireGuard, and it really, you're right, it has emerged as the protocol of choice for a lot of the best VPNs, and it's sleek, it's powerful, it's fast, and it's a lot less complicated than some of the older technologies that VPNs were built around. But from your perspective, what does make WireGuard so good? Why is that protocol so desirable? And then tell us a little bit about, you mentioned Quick. Tell us what that is and how that works. Why do you use Quick? And I think part of the reason that what you talk about is that you mentioned earlier on about trying to kind of maybe mask your traffic's not the right way to look at it, but kind of blend your traffic. So talk to us about the technology a little bit.
Yeah, 100%. I think what makes the WireGuard protocol so desirable, I mean, it is a VPN protocol, right, is just the sheer simplicity of it as compared to OpenVPN. As I mentioned before, OpenVPN was, I don't even think it's right to say it's one protocol. It's multiple protocols mashed up into one with different settings, right?
Right.
WireGuard really came in and said, we're going to be very opinionated about the cryptography and the cryptographic algorithms that we choose so that we can have a very simple protocol. We don't have to negotiate crypto parameters for so many rounds, right? And it also has all of these design decisions that makes it, I think one of the things in one of Jason Donenfeld's slides was that WireGuard actually doesn't dynamically allocate memory before you're fully authenticated as a valid user to the server. So what that means, let's say, to a server operator, is that if somebody is trying to attack your WireGuard instance, it's not going to have an explosive effect, let's say, on your server's processing or your server's memory usage if they are just throwing garbage at you, hoping to overload your server, which I think is very fine design, very, very good sort of cross-stack design there. And so that's sort of why it became the gold standard. And we use WireGuard for sure. We actually layer WireGuard over Quick. And I'll explain a little bit more about what Quick is. Quick is what underpins HTTP3. So when you visit a website nowadays, especially if you visit Google, it's all over HTTP3. When you see HTTP at the beginning of your address bar, that's sort of what that is, right? And Quick is the transport protocol for HTTP3. And so whenever you use Quick and you send Quick traffic to a lot of firewalls and to a lot of routers, it looks like regular internet traffic. It can't really differentiate between quick Obscura or quick WireGuard or quick HTTP3, right? It's fully encrypted and things like that. And so that's why we chose quick as our transport protocol. And back in the old days, and this sort of stems from a little bit of my experience fighting the Great Firewall in China, is back in the old days, people figured out that, hey, the best way to get around the firewall is to look like regular internet traffic, is to look like HTTP2 traffic, basically, back then, right? And to look like regular internet traffic, you had to use TCP, which is what underlies HTTP2, but using that, if you tried to run a VPN protocol over it, you would suffer from the TCP over TCP meltdown problem, as in you'll have stuttery performance, sometimes you see on video calls, it'll just fast forward a little bit and things like that. And I think these are things that people have seen, and it was not an ideal situation because there was sort of now a trade-off, let's say, between, but if you want to access the internet and sort of the smoothness of the internet. With Quick, this problem doesn't exist anymore because Quick operates over UDP. And we can get into the technical details, but suffice it to say that you don't have to sacrifice performance and reliability for the obfuscation anymore, which is why we just have it on by default. And, you don't even have to think about it, which is great.
Oh, yeah. By default is always the best.
Oh, yeah.
There's another company called Safing that they're probably most known for a product called Portmaster, which is kind of like an outgoing firewall, like to keep track of where your traffic's going on the way out, which is kind of cool. But they also have this thing that they call the Safing Privacy Network, which is one of the only other like non-standard, interesting types of VPNs that I've ever seen. And the way they do it is every connection that you make has its own IP address. With a regular VPN, you're connected to the VPN, and then everything comes out that VPN. And for that session, you have the whatever IP address that your VPN provider assigned to you. And so every place you go on the web for that session sees that VPN address. So they could potentially, even if they can't figure out who you are, they could at least correlate, well, this is the same person as that person because it's coming from the same IP address. They have this thing where and it's been a while since I talked to these guys, but every connection is assigned its own IP address. What do you think about that as an idea?
That's very interesting, honestly. Yeah. I think that's very interesting. And I think perhaps it will get more feasible, let's say, as we move into an IPv6 world where, you have more abundant IP addresses. I mean, I'm just thinking about like how they're doing IP management right now, and it's like giving me a little headache. I think it's good. I think it depends on sort of what your security model is, right? And what sites you're visiting and things like that. I think this is sort of why fine-grained split tunneling is so important, is because you just have different security models when you're visiting different sites, right? You can think of it as if you're doing that, you have a different IP per connection. Well, sometimes the website looks at it and is like, well, okay, that's a little weird, right? Like, okay, you're connecting to me through this IP and I'm connecting to my partner. Like I'm asking, client side for you to connect to my partner and you're connecting them on that. Like, what is that, right? Like that might trigger a bunch of, different alarms or things like that. So it all depends. But I think that's a very interesting idea. I think the challenge with these things is always, how should I say this, is always cross-site things. When we load up a website nowadays, you're not just loading up one website, right?
Right.
We're loading up like 10 different websites
or more.
Or more. And somehow Google Fonts is always involved somehow, right?
Yes.
And so, when you do that, I think you really have to think honestly about, okay, what is your trust model there? Do all of them see the same IP address? What if you visit another website that also loads up Google Fonts? Do they see a different one? Or is it per site? It's a very, very interesting challenge.
I know they've had some challenges with that. I know they've had to put in some mitigations for things like that because some websites do kind of freak out. As I recall talking about it. But anyway, I just thought it was interesting, and I just wanted to get your take on that as a VPN maker.
Oh, yeah.
Doing some non-standard stuff. A couple quick things before we go. I know we're running out of time, but you're partnered with Mulved so far. Are you looking to partner with other people? And if you have multiple downstream second hops? Is that something that maybe you'll let your users choose, or will client automatically rotate? What are you thinking about that?
Yeah, but we'd love to partner with other VPN providers for this. I mean, right now we are mostly focused on making our product available on other platforms and things like that, but that's definitely something that we want to do. In terms of choosing Mullvad, they were, I think, taking a look out there, one of the most trustworthy VPN providers out there, right? Yeah. I think when they released the whole account numbers scheme, I was like, this is genius. Nobody needs to did they need to ever know my email? Not really. I just keep getting spam from these other VPN providers. I don't really need. And they were fast to adopt WireGuard, and they even did something that I thought was a little bit crazy. They dropped OpenVPN support, which is, I think, indicative, let's say, of a company that really thinks about, okay, what can we do on a technical level to make everything better, user experience wise, and in terms of risk, let's say, in terms of vulnerabilities and things like that. So we're very happy that they are our first partners. When we do have other exit partners, I think clients will be able to choose, people will be able to choose. Our philosophy with regards to our UI is same defaults, but when we have the time, we allow advanced options such that the user can have more fine-grained control, because we don't assume that the user is an idiot.
And as an engineer, I really appreciate the companies that just have no compromises. They're like, you know what, we could have all this great backward compatibility, but it's clunky, it's old, it probably has bugs in it, and it's complexity that you don't need. And Apple is known for this too. A lot of times, they were the first ones to get rid of floppy drives and, and to move to some of the newer technologies, because the old technologies just sucked. And instead, Microsoft is the exact opposite. They support stuff forever. Right. To a fault. And so I think I agree. I think it's great when companies like, you know what, it's time to just cut. You cut out the crap, slim down, be elegant, be sleek, be lean, and be newer. Be better.
Especially for security-oriented companies, because any piece of code that runs is code that can be vulnerability. It's all liability at the end of the day.
Absolutely. All right, so I talked to the folks from the Tunnel Vision research team, and that was a really interesting. It was almost one of those things like, is it a bug? Is it a feature? It kind of depends on how you look at it, because it was using option 121. It was, it was kind of very technical, but at the end of the day, there were ways that your router could use some of these kind of special options, if your OS supported it, to selectively route some traffic around your VPN link. So I've got to ask, while I've got you here, how does Obscura handle that situation?
Yeah, 100%. I think just to recap for the listeners, sort of how DHCP 121 and everything works. It's so funny that I think a month before they released the paper, I was twiddling around with my own home network, and because I have a couple of VLANs, and the machines aren't seeing each other, and so I was like, well, actually, I can use DHCP 121. That would solve everything. And then a month later, I was like, oh, wait, this is actually something that can be used for an attack. So basically, when you connect to, let's say, a Wi-Fi network, right, the router for the Wi-Fi network can optionally tell your computer, hey, I can also route you directly to these local machines. What that means is directly is important here, right? So, for example, if there's a printer on a network, it can say, hey, I can route you directly to this printer or these devices on the network. And directly is important here because the printer on the network, you don't want to go through the VPN, because that's something your printer's not on the VPN network, right? It needs to go directly. So Tunnel Vision is basically abusing that a little bit and say, let's say we have a malicious coffee shop operator, and he configured his router to say, hey, I can also route you directly to 8.8.8.8 or google.com or all of Netflix's IPs or things like that. And so now all of your traffic, instead of going through the VPN, now goes directly through him and things like that. So it's not an ideal situation. So it's I think here is where, you need to give users the choice because on my home network, I have a DHCP 121 sort of setup because I need to have my VLANs and have things working, right? But in Obscura, we actually just released this last week. We have a toggle that completely prevents this. So if you have that toggle on, it will completely prevent tunnel vision. And this is one of the pieces of engineering that Apple did. It's a flag called include all networks for all the VPN engineers out there. Include all networks basically bypasses the normal routing rules that your OS has set up and says, okay, everything goes through the VPN. And so our toggle says enable strict leak prevention. We also tell you that this also disables LAN access, which is true, because otherwise that's the whole point here. But yes, this is avoidable, and I hope that more OSs think about how to do this in a nice way. I think there's some way of doing this with network namespaces in Linux, but
yep. All right, right now Obscura, I believe, is Mac OS only. So why'd you start with Mac OS? And then what's your roadmap look like for, Windows, Linux, and then mobile, iOS and Android? And I'm really also very curious, mobile's a whole different beast. So are there technical challenges that you're anticipating with mobile that might be different than desktop?
We started with Mac OS. Well, there's a couple of reasons. I think the most basic one was that I use Mac OS on a daily basis. All of our engineers use Linux and Android, so don't worry. I use Mac OS on a daily basis for development. I SSH into my Arch Linux box and do everything. But this is sort of my thin client, let's say, for accessing everything else. And I wanted to make sure. We really, truly do care about user experience here at Obscura. I wanted to make sure that there wasn't any bugs or anything else that the users are seeing, but I wasn't seeing on a day-to-day basis just because I'm not using it every day. And so that's part of the reason why we started on Mac OS. Another reason was that, and sort of coming on the other side of it now that we've implemented everything, I'm not sure if this is a good thing or a bad thing. macOS has a particular API called network extensions. And this network extensions API allows macOS to run our code that processes your packets in a sandboxed environment. And macOS, the system itself, passes the packets through to it and then takes the packets out. So sandbox environment, meaning it doesn't have, elevated kernel level privileges, whereas in most other systems, it would have to be some kind of kernel extension or things like that. So I thought that was very neat to implement. Plus the fact that Apple users seem to care about privacy and there's a large user base and things like that. That's why we started with Mac OS. Our roadmap for supporting Windows, Linux, iOS, and Android is that we are actually going to start with a WireGuard config generator first. This is going to be a WireGuard compatibility mode. So it won't have the fancy quick stuff, but it will be compatible with WireGuard. So on any of these platforms, you can use the WireGuard app to connect. And we're going to roll out clients for fully fleshed clients for all of them. For technical challenges, I think you can think of implementing a VPN, especially a custom VPN like ours, where we're not just taking WireGuard sort of off the shelf and doing that. You can think of it as writing drivers almost, right?
Yeah.
You're sort of writing drivers for all of these platforms. And so there are many platform-specific quirks. I think the most challenging one will be iOS, where, Apple has a lot of restrictions on what can be done and what can't be done in iOS, much more than macOS. But we're able to reuse most of our stuff. I think the biggest technical challenge is reproducible builds on all of these platforms.
Oh, yeah. Wow, yeah.
Well,
that's going to be tough.
One thing at a time.
All right. So last question before we go. What's next for you and Obscura? And what's the best way for us to stay up to speed on all your latest updates?
Yeah. Well, we're very excited. We actually have, our WireGuard configuration generator out right now. I'll send you a link so perhaps you can link it in the show notes.
Yep, absolutely.
So that means that if you're on any of the platforms, and WireGuard is supported on most platforms, you can now use Obscura. We're going to be working on iOS, reproducible builds, and our security audit next. And the best way to stay up to speed on latest updates is to go to our Twitter or Mastodon or Blue Sky or any of those, and we post our updates there and stay stay up to date on those. And for those who are on platforms and you want a fully fleshed out app, just go on our website, click other platforms, and you can sign up for a wait list. We do PGP encrypted email or Noster, any of those.
All right. Nice. I would expect no less. That's fantastic. Carl, this has been really interesting and very informative. Thanks for coming on the show, and I wish you the best of luck because we need stuff like this out there.
Thanks so much, Gary.
All right, everybody. Thank you for hanging in there. I know a lot of that was kind of super technical. Again, you don't need to really understand the details of that technical stuff. Here's the key takeaway for this whole thing. What we're doing with this type of two-party VPN or a two-hop VPN is that we are dividing trust. We are splitting the trust between two other parties. Normally with a VPN provider, you just have your single VPN provider. They are the second party that you are trusting. But with Obscura VPN, we've actually split that trust between Obscura and, in this case, Mullvad, who is another fantastic VPN company, by the way, in terms of privacy and security. And kind of like the Tor network, which if you go to my website and look up onion routing, I've got a whole article on this which explains some of the details and has pictures, which might be helpful. But our traffic between us and our final intended destination is encrypted along the way. And it's encrypted in a kind of a two-layer sort of way, such that it first goes to Obscura. And so Obscura can see that it's coming from us and sees our true IP address. But where we're going, the actual eventual end destination for our packets is encrypted in such a way that even Obscura cannot see that. Only Mullvad can see that. And so it kind of forwards the packets on to Mullvad. And now Mullvad unwraps it, decrypts it, takes off their layer. And so they know that they got this packet from Obscura, but they don't know that it originally came from you. And when they unwrap this packet that was encrypted with their key, they can now see where it is that you want it to go ultimately. And they forward it on. And so, again, there's two hops here. The first hop knows who you are, but not where you're going. The second hop knows where you're going, but doesn't know who you are. And they're two different companies. It's not like it's one company that kind of split this responsibility between two different computers or servers. It's two different companies. So the only way for an external party, let's say law enforcement or a hacker group or foreign intelligence or whatever, the only way they could possibly try to figure out the origin of your traffic and therefore you would be to compromise both parties. We've doubled the amount of effort. And neither of those two parties have enough information individually to track you either. We have split our trust. We've divided our trust. And while technically this could mean that the overall traffic flow is slower, in reality, at least according to Carl, that's not the case. And the other cool thing about Obscura, which I wish other VPN services would offer, and some on different levels do, they've gone out of their way to know as little about you as possible. And I tried this myself. I've done this. I've signed up for Obscura, and I did it with a Bitcoin Lightning Network transaction. I set aside a pool of Bitcoin in an account that uses the Lightning Network and told Obscura to pull from that to pay my monthly bill. And my account with Obscura is a number. They don't know who I am. They know nothing about me. They don't even have an email address. Now, they do know my IP address. And if they were curious, they could probably do some tracking to try to figure out who that IP address belongs to. And this is where it gets tricky, right? We don't know for sure because we can't get our eyes directly on Obscura's servers to see what they do and don't log. But Carl has said that they're doing a third-party audit. That is always a good thing to do. Again, it's not the end-all, be-all. It's not a panacea when we're trying to figure out if we can trust them, but it's way better than nothing. And their willingness to do it says a lot about the company. Now, I already have a VPN. I use Proton VPN because I pay for their service and it comes with the service. So that's the one I tend to use. And I haven't played around with Obscura much myself, but I intend on using it and trying it out. It'll be really nice, actually, once I can get it on my phone. I think that might be where I'd use it more. But anyway, it's really nice to see some real innovation in the VPN market that's truly focused on privacy and not just about marketing buzzwords. Now, Carl mentioned a lot of interesting new tech like Privacy Pass. We talked about Quick and Mask. I have put some links in the show notes to those if you want to learn a little bit more about those technologies. So on Thursday, the patrons will get bonus Q&A with Carl. We get into some even more technical aspects of Obscura, believe it or not. He used to work on Bitcoin. He was a software engineer for the people who worked on the core software that runs the Bitcoin stuff. So we talk a little bit about that. I'll talk a little bit more about how I set up my Bitcoin Lightning wallet and how I used it to fund my Obscura account. And we talk about server-side security and Apple's private cloud compute. So the patrons will get that on Thursday as usual. All right, there should be a big news show next week. I don't know for sure. I recorded this a couple weeks ago, but I assume I probably missed some stories last week because I had to do my news show a little bit earlier than normal. So we'll have a lot to cover in next week's news show. That'll do it for this week. Take care, everybody. Stay safe out there. And until next week, as always, don't get caught with your drawbridge staff.